Okay. Hello, Caleb, if you're watching this. Here we go. All right, so this section is all about collecting data, how to collect data, and how to do experimental design. So there are 6 steps for designing a statistical study. So the first step is to identify exactly what you want to study. Okay, and that is very important. Anybody want to come up with just a fake study that we're going to talk about? Do you know what I mean by study? Okay, so like a study would be like a experiment or a survey that you're doing for something, or an observational study. So let's say that we're talking about, you want to figure out if the kittens that you have in your barn prefer this type of food or this type of food. Okay, so you've identified, I exactly want to know this about the kittens. What do we not need to know about the kittens? What does not matter about the kittens? Right. I mean, you'd probably want things to be kind of like all the same for all the kittens. So it would matter like that they're all about the same age, but it doesn't matter how old they are. It matters that they're about the same age. You'd also need to, like, things you wouldn't need to write down is you don't need to know the color of the kittens. Like, who cares, right? Like that kind of stuff. So you're only going to get exactly what you want to study. The next step is to develop a detailed plan. And you actually want this plan to be so detailed, detailed plan to collect data, that it shouldn't be difficult to collect the data because you already have a plan exactly laid out of exactly what you're going to do. Later in this class, you will be doing at least 2, maybe 3 statistical studies where you're going to be, have you guys ever been asked like a question from a stats student from these classes? So you'll basically pick a grade level that you want to talk to, or the whole school, and figure out what kind of question you want to ask, and then randomly select a thing, and then you have to like have a script where you literally will say the exact same thing the exact same way every time, because you don't want to have any bias or anything like that when you're asking a question. And if you're one of the types of people who absolutely hates talking to people, you can always do like an experiment or something like that instead and just get results. Like you could do kittens and whether they like their food. Okay, next step is to collect the data using your plan. Then you describe the data. Using descriptive techniques, so this might be like finding something of central tendency. That includes like mean, median, mode, tendency. A? That looks right. Maybe it doesn't. Tendency? What do you think? E? A? I feel like A. All right, central tendency, which is mean, median, mode. Or maybe you want to like have some graphs or something like that where you can look at trends. You might be able to find standard deviation, that kind of stuff. The next step is to interpret the data. Spelled that wrong. To interpret the data and make decisions about a population. For example, if we're talking about kitten food, I could start looking at, all these days and all these trials that I did with these kittens, and they preferred overwhelmingly this kitten food to the other kitten food. What is an inference I could make about the population then? Like, what could I say about all kittens then? They like that food compared to that food. Is that true? That all kittens prefer that? Not necessarily, but that's the inference, okay? So up until here, this is all facts. And this one is a guess. It's a good guess. It's a guess based on science that we did, but it is, again, just a guess. And then the last step, which is the most important, is to identify any errors that you have in your study. My dad was a psychology major in college, which is crazy because then my dad literally, when I was a child, was a parole officer. Isn't that fun? Okay. You might think it's tough having a teacher who's like a parent in this school, but try having a parole officer as a father. But he, in his psychology courses, he had to do like his big like thesis statement at the end. And it turned out, he realized afterwards that all of the work he had done for his thesis was completely wrong because he had messed up a part of his study. And so he had to go in and present and basically be like, here's my data, here's my conclusion, and everything is completely wrong because here's why I messed this up. And they gave him an A on the project because the most important part of being a scientist is realizing when you've made mistakes or what possible mistakes you could have made and adjusting. So that was good. Okay, there are 4 ways to explain, to collect data. A survey is just asking questions. I'm starting on the second one. What's a problem that could happen with asking questions of somebody? How they ask it, how you ask it for sure. How it's worded, yep. It's another problem with asking questions. What if I say to every teacher in this school, how old are you? Will I get all the right answers?
Yeah.
I could. Could they lie to me?
Yeah.
Sure. Okay, that's the biggest problem. When you're doing a survey, people can lie. In fact, that's what happened the first time Trump was elected. Do you remember how they had like a whole bunch of things out there that were like, yeah, definitely the other candidate, Hillary, right, was going to win. And like everybody, all the newspapers were like, Hillary's going to win, Hillary's going to win. And the reason why she didn't win is because A, a lot of people changed their mind at the last second. B, a lot of rural districts were not actually like more urban districts than rural districts were asked their opinion, and rural districts tended to go towards Trump. And the other reason is because people straight up lied when they were responding and said that they were either not voting or that they were voting for the other candidate instead of the candidate they were voting for. So it's possible even when you have enough questions out there that you're not going to get the right answer because people are not going to be truthful or factual. Okay. Next up is a experiment. This is a control group and a treatment group, which we'll talk about in just a second. You only manipulate one. Do you guys know what that means? One factor. Okay, suppose I have two things that are happening. I've got like a control group and a treatment group. Do you guys know what a control group is? Surely you do. You've taken science classes, right? Right, control group is the group that does not receive the treatment. The reason why they don't receive the treatment is so that you can compare them to the treatment group and see if anything has changed. They will often give somebody a placebo. Do you know what a placebo is? What is it? Yeah. Right, this is a fake pill. When you take a fake pill, and somebody claims that they have a reaction, like suppose you're doing some sort of test and you're like, I want to see if this helps with depression, okay? And then somebody takes a pill and then they report that they're feeling a lot better. Does that mean that they're lying? No, why not?